Good afternoon, and welcome to this afternoon's Plant Engineering webcast, Asset Condition Monitoring, Best Practices to Maximize Benefits, sponsored by L&T Technology Services. I'm your moderator, Bob Amber. Thanks for joining us today, and Plant Engineering and CFE Media welcome you to this afternoon's webcast. Here are some tips for you to get the most out of today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or the slide presentation, click on the question mark at the top right-hand corner of your screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. You can type questions for our speaker in the Ask a Question box on the left side of your screen. The Q&A session will begin after the presentation concludes. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of this webcast. Now we'll hear from the sponsor of today's webcast, L&T Technology Services. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for today's presentation. We're very pleased to welcome our speaker for this afternoon's webcast. Sriram Shanbhag is the Global Head for Manufacturing Operation Management Services at L&T Technology under their Digital Manufacturing Services division. Comes with more than 25 years of experience in core manufacturing industries and in related fields of process and application consulting. His expertise spans across industries such as chemicals, oil and gas, industrial discrete, life sciences, and IT services. He's also well-versed in practice leadership, building competency units, centers of excellence, right sourcing deals, strategic systems consulting and supply chain, manufacturing operations, life sciences, product selection, and solution implementation. He continues to provide insights into the adoption of digitization, smart and brilliant factories, controls and automation, MES systems, asset management, solution architecture, IT outsourcing and transition management, training, mentoring, and coaching. Sriram, it's a long list of things that you're expert at. We're looking forward to having you share that expertise with our audience today.
Thank you, Bob. Appreciate your support. Welcome everyone again, and thank you for listening in. So today, in the next 35-40 minutes, I will be taking you through our point of view in terms of the digitalization of asset maintenance. We do understand the asset condition monitoring is one of the key areas of our industrial operations. Though the asset life cycle is something which includes the asset planning, asset acquisition, the operation and maintenance of the asset, and the asset, of course, retirement and disposal. However, for today, we will focus mainly on the digitalization of the asset maintenance itself. As part of this session, I will focus on the current shape of the asset maintenance, where the industry is at, and also what's the road ahead, what's the various ways and the options of digitalization adoption that we are looking at, and of course, some of the very brief on the L&T Technology Services, the expertise and the work that we are doing. When it comes to asset maintenance, we still continue to have higher cost, some of the unpredictable aspects of the asset behaviors. Though the assets have been acquired in a very structured manner, but we also see lower in-house expertise in understanding the engineering or the design criteria of maintaining an asset. Of course, the plethora of legacy that is associated with the assets which have been there for 20, 25, 30 years. There is enough information probably which is being collected, but it's in a very silos and not being collaboratively utilized as a knowledge base. Continue to have a standard operating procedures in a traditional way, which of course is governed by the preventive aspects of an asset that we need to maintain. As we have seen the industry moving along, it's been the pressure on the asset side of it is that there is a reduced time window which continues to be provided to maintain an asset, which means there is a more and more an opportunity to make sure that the technology, the current, with the advent of the new technology, we are able to utilize that so that, we have the reduced time window which can be utilized effectively for maintaining an asset. What we have seen on the right hand side of the slide that you will see is there is a very recent survey that was conducted and from specific to asset maintenance, and we just went through the various criteria, and accepting the leadership priority and the senior executive buy-in, the rest of the infrastructure, the internal expertise, the data transparency, and the intelligence on the asset that people own, they were not even ready up to 50%, which means there is a definitive opportunity for the digitalization of the asset maintenance and the entire process. Traditionally, I'm sure most of you have been doing this, that you know the location of your assets, various types of assets, and of course some of the key data and the behavior and the way that the preventive maintenance needs to be done. However, are we ready for the the digitalization of this asset maintenance so that we are able to increase our asset availability, safety, and also the longevity of the asset that we are utilizing. Now, having said that, the typical challenges still continue to bog the asset maintenance. We see that there are pockets of automation and of course utilization of some ML-based failure detections and predictions. So it is basically the industry is moving from preventive maintenance to the predictive maintenance. So this is we see on the horizon a stabilization of predictive maintenance happening. For that, we see various ways in which the current trends are impacting. One is, of course, the closed loop asset maintenance planning. It used to be predominantly manual, and then looking at how the OEM vendors have provided us the various asset plans, asset maintenance plans. But looking at the asset behavior, we have seen that the maintenance planning and the scheduling is getting automated fully, and we are taking the feedback from the plant floor and the asset floor, and in predominantly where it's an asset intensive industry, we are able to close that loop and see if we can utilize the feedback and then adjust the schedule as and when needed. At the same time, we are also looking at failure reporting improved very significantly, wherein in real time, we are able to definitely get alarms, notifications, and be able to escalate and sustain it. We also looking at tools and parts because once an asset is invested on, every customer tends to look at what are the various tools and parts that we need to keep in our inventory, so that we are not looking at any downtime because of the lack of tools and parts. But with the advent of technology and supplier coordination, there is a lot of automation which has come into picture. At the same time, we are also looking at machine learning based failure detections. That's another trend which is picking up, and this is something which is pushing most of the industry from a preventive to the predictive aspects of it. And though it is in a very nascent stage, but this is something which is going to be predominant in the coming 2 to 3 years, and which will definitely improve the overall asset maintenance which is being done. The robot-assisted repairs are something which is also coming in predominantly in the automotive and the discrete side of it, where robotics has taken much to the entire asset repairs and everything. Drone-based inspections, definitely, where there are remote assets, there are huge pipelines and various types of assets in the remote locations. Drone-based inspections are also allowed. Of course, there are certain local regulations which are driving this a little, hampering this growth, because right now in most of the countries, if you see, the local regulations are that you cannot fly a drone above 100-meter range, and then so it becomes a little bit of a challenge in terms of you really utilizing this. But within the factory battery limit or the campus of your own, you can definitely utilize the drone-based inspections. But all in all, what we are looking at is the overall industry is moving towards making sure that there is a strategy that is in place for asset maintenance, which can take care of the availability, safety, and reliability aspects of it. That's how we have seen the key trends impacting us. How do we see, when it comes to the real digitalization, how do we see the road ahead? We have been, of course, we've seen the descriptive maintenance. Some of us may still be in the descriptive to preventive aspects of it. However, you see the star there, which basically indicates the on an average, the overall industry ecosystem has embarked upon the predictive maintenance, and the predictive maintenance is something that's going to stabilize for a couple of years. Now, from preventive to predictive, the industry has taken significantly a high number of years, almost 15 to 17 years is what, we understand. Whereas the next step, that is from the predictive to the prescriptive. So when I mean prescriptive is basically the system will be able to tell that, okay, in case of this such and such an issue with an asset, it will be able to say what are the various options, what are the solutions to be addressed, and how do we take it forward, and how do we maintain the asset. That's what the prescriptive maintenance relates to. But the key thing is the preactive maintenance. Preactive maintenance is where you have a digital twin specifically developed for maintenance. Yes, it may not be in in real time, but it will definitely be sufficient enough to provide the asset maintenance plan and the schedule to be maintained. This is something that we foresee that there is a chance that the movement from predictive to the preactive will be in a single jump, wherein the prescriptive will get I would say absorbed into the preactive aspects of it. That the digital twin, which is coming in from a maintenance perspective, will be the one which will definitely highlight and take away the prescriptive aspects of it, and still be able to sustain the availability, safety, and the longevity of an asset. However, again, we see that from preactive maintenance to maintenance 4.0. See, the maintenance 4.0 basically is something where you are looking at a self-repairing asset. This is something we believe it is still going to take a long time from preactive to the maintenance 4.0, if you will. That's the road ahead as we see, in terms of the current ecosystem, the industrial assets. However, the expectations from any specific customer continues to be that I have any type of industrial asset, it may have any type of a sensor, and I may have already invested into various IT, OT, architecture, and will I be able to sustain and have the same type of digitalization that can I do it? I may also have various types of platforms that I'm looking at, and I may be just beginning at predictive maintenance. Will I be able to get all kinds of analytics that I can develop? So the solution that we are looking at, while adopting a digitalization for asset maintenance is these are the various criteria it should be able to handle. But the simple way to adopt is that we look at connectivity. So what we have seen in many of the customers, and we have worked with various, I would say, the OEM vendors as well. Looking at that is the three key pillars of simple approach to an adoption is looking at the connectivity of assets. That is to take care of the not only the operational data but also the health data. Looking at the equipment engineering data, the maintenance data, and calibration data. So all aspects of the data of an asset, if we can make sure that we are able to gather either through a direct connectivity or through an indirect connectivity, I think the asset will be ready to be maintained appropriately. Once the connectivity is established, the controlling of the assets becomes predominantly important. When we mean control, it's not that we build a firmware or something like that, which may already be there with this asset. However, we are looking at building a certain traditional control or a master slave, which we are able to look at various what if scenarios and be able to control it, or even a multivariable controller, which is an advanced control type, or of course a supervisory and the remote control type that we are able to sustain this. Most of the assets that we have seen and we come across, of course, they run on their own. They don't need a control intervention as maybe, because they are given a specific task to be done and which they are good at doing, and that's the reason we do have these assets invested in. When it comes to cognition of the assets, of course, this is where I was saying the road ahead is we are at about a predictive maintenance level. We should be moving towards reactive very soon. This is what is the expectation. And do we wait for all of our assets to be connected and then only look at the control and cognition? No. We are looking at making sure that we have a closed loop for at least a single value stream or a single section of the plant where we can take care of the different key critical assets and then be able to start the adoption. When we continue to move towards adoption, it's not just the technology or it's not just the usage of the digital technologies, but at the same time, eventually it has to be what are the various use cases? What is the business outcome? How is it impacting my day-to-day business? So the three key roles that we foresee when it gets impacted from this aspect of our strategy is one is the asset, of course, the maintenance operator, then the maintenance supervisor, and of course the maintenance manager or the plant manager. So on the manager, it could be any stakeholder at the managerial level. So we need to definitely keep in mind that there is a appropriate role-based human-machine interface that we provide, the status of the asset, so that there is at each level, whether it's the maintenance operator level or the maintenance supervisor level, we are able to give the right information at the right time so that they are able to take care of making sure that the asset maintenance process takes over, and then they go through the overall structured either the escalation or the review or even just making sure that there is a electronic maintenance record that is that can be made out of and then stored and then kept appropriately. The additional tangible benefits of making sure that the digitalization of asset maintenance happens is that every downtime or on every incident can definitely be looked into, analyzed, root cause analysis that can be done. We can also do a lot more of heat map analysis. When we mean heat map, we're talking about prioritizing the assets for taking up in the shutdown, for example, a shutdown maintenance, because we may have all kinds of assets. Shutdown may happen once in a year, and it may be for a very fixed period. So it depends on what's the priority that we can assign to various assets, how do they pair against each other, and every other aspects of can also be analyzed and kept ready. So we don't have to do an elaborate shutdown maintenance plan, but definitely if we have the real-time data and the information which is coming in from a digitalization, then it becomes very easy for us to plan for the shutdown as well. So keeping in mind that we look at a very simple way to adopt digitalization and asset maintenance, and keeping in view the various role-based use cases, what is it that we look at as a solution here? The ARC here stands for the Asset Reliability Center. So a typical asset condition monitoring solution that we look at is there is appropriate connectivity and we are getting the right data. It is not that it's noisy data or it's incorrect data. So we're looking at various types of connectivities which are robust enough, have based on various standards, and then we can definitely look at various sensorization that is possible, and be able to connect to those sensors so that we collect the right amount of data in real time and be able to utilize it for monitoring and notification. So the second step to arrive at in terms of the condition monitoring is that for these all the parameters, are we able to monitor effectively and be able to get the right notification in real time? Once that is done, so you have the visibility and you are able to monitor, then the historization, because history data is very, very key and predominant if we have to really look at going into an additional steps of cognition wherein the analytics becomes more and more important. So keeping the history of the behavior of an asset, including the maintenance and calibration data and various interventions or the replacements of parts or any aspects of it, will always go a long way in terms of making sure that the analytics piece will be able to predict properly and be able to take care of the digital twinning, everything. Now, that's the next step. That is, we look at the reactive maintenance or a predictive maintenance. We can use analytics at any level that we have seen. We have worked with a smart SCADA as well, wherein we are able to use various small analytics pieces which can be deployed, and we can consider a very, I would say, localized analytics pieces which can be utilized to predict only certain behavior and certain product signatures, for example, or a behavior of a asset itself. Given the localized implementation of the analytics. However, we've also seen that the similar reusable analytics pieces can be utilized for intuitive utilization of asset behavior, because one type of an asset, when you look at a motor or a pump or a generator or any specific type of an asset, unless it is predominantly I would say, special purpose machine, we always see a typical behavior. We know the certain specific condition monitoring attributes that we can monitor, as well as be able to predict easily. So there is a reusability that is possible at the analytics layer, and we have seen it definitely makes a lot more use when we are making sure that these analytics pieces are developed in a very modular manner. Now, standardization of asset framework is something which is predominantly there from an asset management perspective, but when it comes to asset maintenance, that's where we would like to that if we are able to look at the behaviorally, if there are certain types of assets which we can combine and make sure that there is a corroborative evidence that we can attach to in terms of an electronic maintenance record for each asset, then it will go a long way in sustaining the asset maintenance and making sure that the condition monitoring gives us the right kind of benefit for the investment that we will be going through. Now, do we do this in a I would say a hybrid solution? So, or do we look at it in a very incremental way? So we can do it both ways. That is, if we have invested into automation where the various data, the condition monitoring data or the asset-related health data or any type of data that is coming from an asset is through an automation layer. That is, you have a control system, you have a SCADA, you have a historian, then that is fine. But at the same time, do we go and revamp everything to automate and then go for an IoT device, edge device and edge gateway where we can capture all the asset-related data? No. What we look at is a hybrid solution, and that has been most successful in most of the prospects that we have worked with. That you continue to go with a hybrid solution wherein you have your legacy equipment, but you also have your automation that is there predominantly from a connectivity and control perspective. But there are some assets which definitely need additional hardware that needs to be put onto them from an edge IoT perspective, so that you are able to connect and collect various condition monitoring data as well, and then take all of this data to an application layer. It could be an IoT layer or it could be simple on-premise application layer wherein we are able to run the predictive models and will be able to handle this. Now, which means the solution should be able to leverage the existing investment. This is exactly what we are proposing currently in the overall adoption. It can be a very well an incremental adoption of each and every feature that you will need in the overall digitalization of asset maintenance. But it will be in the long-term strategy view. That is, it will take you definitely towards the maintenance 4.0. However, it can be outcome-based. You can definitely formulate various business cases for even the individual investments, so that you have the control over what's the value add that you've got for the immediate investment that you're doing in this. One another advantage that we have seen keeping this solution in a service-oriented manner, that is, you come out with a specific modular service for a specific asset type or an asset, then it becomes far easy from an extensible and a scalable perspective. And we also see that this solution need not be put in place altogether at one go. You can incrementally build this over a period of time. So that's the advantage that we have in terms of looking at it as a asset reliability center, that you start with the connectivity, you then move on to the control, closed loop control, and then you can definitely look at the additional cognition aspects that are needed in this solution. A typical solution component that we foresee in this asset reliability center can be that you have individual key critical assets, which maybe you may have only 20 machines which are very critical to you, and you need a proper digitalization of those assets. Then definitely you can look at going with an edge gateway for that specific asset and take all the data onto the analytics platform. It could be an application layer or it could be an on-premise server, and then go through the various initially, like I said, go through the monitoring, visualization, and then slowly build on top of that in terms of looking at how the overall history data looks like, and then be able to train your analytical models to take care of that. So this asset reliability center can focus on a single asset and also to look at the entire plant. So and also looking at remote assets. For example, in terms of our the overall reliability center, if there are remote assets, we can look at remote asset performance, and then most of it is going to be that your edge analytics and the edge behavior is going to be different. You can have a different types of connectivities, be able to bring all the data either through the private cloud or public cloud onto your application layer and be able to do the analysis of the entire data. Barring that, I do not see any difference in terms of how you manage. Of course, you can have various types of geofencing and various types of functionalities can be looked into. However, from a maintenance perspective, it is far more easier monitoring any asset, which definitely is movable or immovable. It does not matter as long as the connectivity is robust enough. And there are various technologies now wherein the edge is far more becoming, I would say, robust enough. That is, the edge is now capable of buffering the information, is able to control, and is able to also have a an analytic component so that it does not have to send all of the data to the master server or the cloud. So given that kind of capability, I think we should be able to harness and be able to maintain these remote assets as well, as if they are part of our plant battery limit. We also have seen that we can build on the real-time analytics as we go along. We don't, as I said again, if you look at it from a service-oriented perspective, it can be fairly modular. We don't have to have a large analytics engine which takes care of, say, 10 to 12 aspects of your predictive or the reactive aspects. You can build on this in a very I would say incremental manner. Identify the problem, look at it, what is the various, say, we have looked at a couple of cases where there were very specific aspects of, say, a motor burnout and the chronic issues, the pain areas. So we looked at them very specifically and then worked on them to come out with a very modular, because there are various types of predictive aspects that can be looked into. Machine learning, of course, is one of the key ones. However, there are many statistics-driven, engineering-driven analytics pieces which can be utilized. So we are agnostic. We do not say that it has to be always engineering-driven, but we have seen the success rate of an engineering-driven analytics piece is far more than statistics-driven. That's our experience. So it becomes far easier that once you have the basics, based on the physics and the engineering aspects of the asset behavior and the asset mechanics that is involved, it becomes far easy for you to train that model and make sure that it can definitely be able to provide you at a very high probable way, and also in a very early detection is possible. Now, the real-time analytics, when we talk about in this entire asset reliability center, the solution can definitely be reused in any of the stack. That is, if you have a decision support, for example, not only from an asset maintenance perspective, but also from asset management, in a larger way, you can utilize that and then see how best you can scale it up and extend it to the catalog of assets that you may have. Here, the expectation is that when we mean real time, it may not be as mission critical as it may be for certain operations or the manufacturing operations that we see. However, when we do a condition monitoring, I think it has to be near real time, but the analytics piece can definitely run, a little slower than the connectivity and the control aspects that we look at, and when it comes to the asset maintenance. So, as I said, this asset reliability center definitely can be looked at, that you can go modularly. You can build various aspects of it. You can look at alarm notification. You can look at the reporting modules. So you can build on this in a very, if you are not an asset intensive industry, then you can look at a very light reliability center for you, and then you focus only on the need of the hour, as well as looking at how you can utilize this. If you are a moderate industry, then probably you would like a little more in terms of building the overall system dashboards and making sure that the synchronization with the closed loop asset planning and scheduling happens. But if you are completely highly asset intensive, where assets are the key aspects of your industrial life, then definitely it makes sense that you have the various managed services which are running for you. It could be starting basically with connectivity and machine care, as I said about a single asset and the machine care. But as we go along the road ahead from the road towards maintenance 4.0, the monitoring services, the reporting services become very, very essential. But the predictive aspects, the root cause analysis, making sure that the electronics maintenance record, that we are going to store for each of the asset, for the post facto analysis, as well as to see if we can predict its behavior as we go along, it will be more and more predominant. So we can look at this asset reliability center in a very light manner, and the various aspects of the managed services can be looked at. You can definitely work with a service system integrator as well, if you will. And then the typical implementation model that we foresee in most of our engagements and assignments is that once you have this, the reliability center devised for your own, I would say industry or your own asset ecosystem, you can definitely do a asset reliability template, as we call it, which then basically deals with what is the various kinds of assets and what is the intervention that is needed. And you can utilize that ART, which is asset reliability template, and implement it for one value stream or one section or maybe one plant where you have the key diverse assets. And hence, I would say that from a proving of or a proof of concept or a piloting of ART will give you a confidence that yes, what you have built as a solution for yourself from from the digitized asset maintenance perspective can be easily scaled up and extended to the remaining assets across the sites that you may have. And of course, we cannot forget the steady state support and maintenance, because once till we go to a maintenance 4.0 scenario where there are self-repairing and robotic assisted repairs happening to the assets on their own with minimal human intervention, I think it will definitely need that there is human intervention that is continues to be there from a sustaining this I would say the asset maintenance process itself. So to recap, from a strategic point of view, we need to have, we recommend that, there is an asset digitalization strategy. You may already have one. You may have a larger digitalization strategy from an IT perspective or a manufacturing IT perspective, but it would be great, if you are asset intensive industry, we suggest that there is a definitive asset digitalization strategy which can definitely build on the foundation, look at the incremental innovations, and also be able to have a continuous improvement mechanisms inbuilt into the entire strategy. And I have also, elaborated that, leadership buy-in, a top-down perspective and the bottoms-up approach. That is, the leadership buy-in that, they prioritize and, of course, allocate due budget and funds for this, as well as that there is an executive buy-in that, yes, there is a scope for improvement, because most of the time there is always a resistance saying that, yes, we have achieved whatever is needed and we are doing whatever is required and whatever needs to be done. But with the advent of this cutting edge technologies, there is definitely improvement that's possible. And as I indicated earlier, that the readiness of most of the ecosystem currently is only about 50%. That is, there may not be complete enough infrastructure to move towards a maintenance 4.0. I think that's one of the areas that we foresee from a strategically. It makes sense that you have a asset digitalization strategy. And of course, it's not like once you have done it, you continue to hold on to it, but there can be a realignment that can be done regularly to look at it and then collaborate with the way that the technology is improving and the disruptions are happening. And also to recap from a tactical perspective, we see that there will be definitive improvement in the analytics pieces. You will see a lot more service-oriented or the microservices that will be able to come in where we can do a risk-based visualization. Fault detection can be, of course, improved very high, at a very high level. We can look at various KPIs. I'm talking of only the KPIs from an asset maintenance perspective, and be able to enable the entire asset reliability. We also seen that there is a steady state and dynamic simulation which is coming into picture from an engineering perspective. And this engineering excellence, process excellence, and the operational excellence, all these three pillars will converge into when the digitalization will happen. And hence, the KPIs, for example, the risks that may be involved and the fast fault detection that may be required, all the even, sustaining a root cause analysis knowledge base, for example, will all propel towards making sure that, you are moving towards a maintenance 4.0 scenario. So I would now look at what's the various aspects of L&T Technology Services in this. L&T Technology Services, of course, we have a larger framework, and looking at as you can see, we have a smart manufacturing framework where Asset Reliability Center is one part of the overall solution. However, we can definitely look at complete manufacturing engineering, manufacturing collaboration, as well as the enterprise enablement. So we have the services offerings and solution accelerators, driving most of these offerings towards a smart factory. When we mean a smart factory, of course, it involves that we can move the maintenance, asset maintenance, as well towards a maintenance 4.0, because this entire thing has to be, there cannot be a single constraint that will remain in a legacy form, or there cannot be a bottleneck that will remain, so that the factory can definitely consider itself as a smart factory. So the vision being a smart factory, for example, your asset maintenance will also move towards maintenance 4.0, and that's where the overall Asset Reliability Center is coming into picture. Yes, as L&T Technology Services, we have done enough interventions, digital interventions, be it overall equipment effectiveness, or even a simple, I would say, a global energy metering and energy efficiency program. We have run a program like this for a customer, wherein our focus was only making sure that the entire energy metering is taking place, not only about the simple utilities, but also of all the assets. What's the various energy that is being utilized, and how can we make it more efficient and ensure that we do not impact the asset as well. So that's one of the aspects we did, which was very, very satisfying. Similarly, we have AR, VR. There are cutting edge technologies which can be utilized, so that we can improve on the smart manufacturing interventions. So given that we have the various experience and the offerings and the solutions, our credentials are very good. We have deep manufacturing insights. We do adopt cross-industry good practices. We have experience in similar engagements that we have built a digitalization strategy, not only from an operational perspective towards a smart factory, but also driving the asset maintenance towards a maintenance 4.0. We have value-added services like consultative services. We can come in, do an assessment for you. We can provide you a roadmap, and we can also devise a asset digitalization strategy for you. We have a flexible methodologies. We can adopt various aspects of the smart factory vision. We can look at the various risks, and IT/OT risks are something which are also predominantly coming into picture. We can look at working on the business case formulation, so that there are direct benefits. We are able to optimize the costs, be able to reduce the risks, of course, because asset maintenance, driven sometimes by the risks that we foresee, and be able to retain the knowledge that has been there in the overall asset behavior, the way the asset has been maintained and everything. So we can provide you we can be your partner from a long-term sustenance perspective, leveraging your existing investments and propelling your movement towards a maintenance 4.0. So I'll pause here, Bob. I think we are at the end of the session now, and I would request if we can take some questions.
That'd be
so
great.
That it will be, yeah. Thank you, Bob.
Thank you very much, Sriram, and we'll get to all those questions in just a moment. If you've got questions for Sriram, type them in the Ask a Question box on your screen. The questions we don't get to today will be answered via email within a week. And remember, to download a certificate of completion and a PDF copy of this presentation, use the Event Resources tab on the left-hand side of your screen. We've got a lot of questions that have come in from the audience here this afternoon, and we want to get to as many as we have time for. Let's start here. How does vibration monitoring compare to electrical parameter monitoring for understanding equipment condition?
Yes. So typically, I would say, what we have seen is these are complementary. We would definitely like to know the equipment condition. Most of the time, vibration monitoring yields better results than focusing only on the electrical parameters. So I would say that both of these parameters can be utilized to understand the equipment condition. Can we do better? Yes, it would be better if vibration monitoring, because even with electrical parameter changes, they may not be easily. It may not be easy for us to detect the overall equipment condition unless the electrical parameter, like in a CNC machine, the quality of electrical power is very, very important. So yes, it makes sense there. However, is it across for all the typical assets? No. I think I would say vibration monitoring is far better. But if we have both, yes, they can be complementary.
Yeah, and that's a really good point, because vibration monitoring has been the standard for decades, really, in terms of trying to understand equipment health. But now we've got some things that, some strategies that can really enhance what you're already doing, rather than just concentrating on the information you can only get through vibration monitoring.
Right, Bob.
Another question, are there monitoring equipment and techniques available for CNC machining centers? How do you predict something if there's going to be a failure during machining, machining close tolerances and high levels of finishes? We've not seen any widespread monitoring equipment or techniques for CNC machines. However, there are some systems like Simco or Scout systems which probably you can explore, though they may not be, very predominantly only utilized for CNC. What we have seen, however, is many OEMs which are producing these CNC machines are providing custom apps for their own CNC machines, so that one is able to monitor at least the critical health parameters of a CNC machine. And this is something which is very, very a good shift that we have seen, that the OEM vendors are coming in and are able to provide you the custom apps directly where you are able to connect. And of course, some of this is, I've come across one of the vendors where you just have to have an app on your mobile device, and then you can definitely connect and then be able to see all the health parameters of your CNC machine. And that's the kind of openness that is coming into, and hence, it makes, it is, I would say that the jump from from a predictive to the next level is definitely going to be very, very quick and disruptive. Yeah, and we're seeing the same thing as well as we talk to plant engineering readers about this topic, is that we've already seen the migration from preventive to predictive, and now, as you discussed during the presentation, prescriptive is the next threshold out there.
Right.
It's going to be very interesting to see how quickly that really develops. You see that happening more quickly than once it does start to happen, it's going to happen pretty quickly?
Yes, it will happen very quickly. At the same time, as I said, there may be a jump that some of us or some of the industry may move from predictive to reactive, that is, adopt the digital twin for maintenance directly, and taking the prescriptive aspects as part of the overall jump as well. So that's also something that we foresee happening in most of the asset-intensive industries. And yes, we can. I would give hardly another 2 to 3 years where the prescriptive aspects definitely will be in vogue. At the same time, reactive will start overlapping onto it.
Great. Got a couple questions coming up now about some of those things you just talked about. First of all, how do you see IO-Link helping asset monitoring? And on that same note, how about some other communications protocols, including industrial Ethernet or wireless?
Yeah, any communication standard like IO-Link, facilitating data transparency is always helpful in asset monitoring. barring some critical assets which are in very highly mission critical operations, whatever may be the communication mechanism, as long as the data that is being obtained is clean, is provided, provides the true status of all the asset parameters, then I think we should be good from an asset maintenance perspective. But at the same time, with the advent of smart sensors, it is always helpful to have the latest upgraded communication infrastructure, because the advantage that you have with the upgraded communication infrastructure is you are able to do a far more better job in utilizing the data and information and be able to close the loop with an appropriate analytics is highly probable than if you have a very slack communication infrastructure and your data is not proven, or there is a lot of noise, or you don't trust your data. So it makes sense that we have the upgraded communication infrastructure. Ethernet definitely has been most widely used protocol for high-speed data transmission, but wireless definitely is picking up. The only concern that it probably still has in various pockets of the industry is about the data security when it comes to wireless, because that's probably an intrinsic, I would say, the business change that may have to happen. Though it is proven that it's not it's as robust as wire speed transmission, but wireless communication will also be very predominant when it comes to complex assets and single and critical assets, and of course the remote assets. So I would say IO-Link definitely helps, and any type of industrial communication, which is the latest one, upgraded one, is definitely should be that one which we should go for.
Very good. You mentioned digital twin a little while ago. Question is, what are some of the open source tools available for digital twin?
Yes, there are, but see, I would like to caution here that when it comes to open source, they will actually give you a backbone or a foundation. They may not give you the equipment physics or the engineering design criteria that may be involved in your asset. So yes, there are something to name a few, maybe Eclipse Ditto or a Mago 3D. There are various aspects of these open source that you can definitely look at, but most of these will give you mostly the foundation or a backbone, and then on top of that you will have to definitely understand and then build on, and then make sure that you have the equipment physics and the engineering criteria which is coming into, without which the digital twin will not be something which will fly. So I would still say that yes, open source is something that you can always try out, which will definitely it's excellent from a learning perspective, and also from looking at how best you can utilize any of the existing I would say enterprise systems which can give you the actual digital twin, for example, or the commercial. So you can compare them and see. However, as I said, you will have to build your own equipment physics and engineering criteria on top of these open source tools that are available.
Very good. Another question, how do you identify the level of asset condition monitoring, and what are the factors?
This is very subjective. It's an interesting question. I would say that unless we have appropriate, that's where I was saying that we need to have a roadmap towards maintenance 4.0. I would urge everyone that there is appropriate digitalization of asset maintenance. A strategy is that you have a direction set. Of course, it may take some more time than the other, but other industry or other form of growth that is happening in digitalization. But if there is a direction set towards that, then it becomes easier for us to define what's the various KPIs and how do you assess yourself. Because rather than comparing yourself with any other, I would say when it comes to real asset maintenance, it's the assets that you own and you are responsible for is something that you can definitely work with, and you can work with your own pace to basically evolve towards maintenance 4.0. Yes, you cannot completely forget the competitive advantage that you will be getting in. And hence, I would say look at the maturity at all the three levels. That is, are all your assets connected? Are you able to get the data that is needed, which is clean and clear enough? Then look at, are you able to control your assets, and are you getting any additional analytics on top of the standard, the HMIs or the user interfaces or the trends and other aspects that you are getting? Are you able to build on and then having an additional analytics which you are able to get more insights into your asset behavior and asset condition, and are able to, I would say, improve upon the key parameters, like, for example, improvement of the productivity or increasing the asset life itself, longevity of it, making more and more reliable, assets as part of your overall operations. So are you able to really impact your business outcomes which are tangible enough? So if you foresee all these things, I think then you'll be able to identify the level of condition monitoring that is needed and what are the factors that may be involved in it.
Very good. Got time for a couple more questions. This is probably my favorite one so far today. We write about maintenance as a profit center all the time. So can you talk a little bit about how condition monitoring helps to improve productivity?
Definitely, if you look at plant uptime or the asset life itself and the asset related quality, as long as we are able to increase the uptime, we are able to increase the longevity of the asset without any quality issues, then the condition monitoring is always helping us. So there is no question about whether condition monitoring helps, but how much of it can it help? So if you are, a place where you have never looked at your traditional preventive maintenance in a very structured manner, then you will definitely see a drastic change. The moment you improve upon and then visualize your asset maintenance, you will see a drastic and an exponential, I would say, improvement. So once there are of course various asset performance management tools only for asset performance, but when it comes to analytics, definitely there is something that you will have to look at and build for a downtime analysis, or for example a fault detection, product prediction, for example, or a closed loop root cause analysis that you would like to do. And also as I did not elaborate a little more on this, that there is something called electronic maintenance record. That is, if you are able to, at the end of the shift or at the end of the day or even at the end of the week, for example, if you have been running your asset 24/7, then are you able to see what is the real wear and tear that may have happened? Are you able to predict and then see what's your remaining life? Are you really moving towards that, or do you have to take care of the asset maintenance? So if you are in tune with what really is happening to your asset in real time or even at shifts, and then to get out and be on top of that, then you have definitely an edge over making sure that the plant productivity can be taken care of. Now, of course, the plant productivity is not just because of the condition monitoring, but there are various aspects involved in the plant productivity. But if we are able to sustain the asset performance and the asset reliability overall for the period that we want to monitor, with the advanced features like the vibration analysis, the ML-based fault prediction, closed loop root cause analysis, automated project identification for the shutdown, and equipment learning itself. That is, if we are able to learn about the equipment by monitoring the various data, then I think we would have done the job of making sure that the plant runs always, and then asset is not the issue or the problem for a plant productivity. So as long as we are able to take care of that, I think we are good.
Very good. Well, we're going to leave it right there. It's a great way to wrap up this afternoon's webcast. So I want to thank Sriram Shanbhag from L&T Technology Services for his time and expertise. And we want to thank L&T Technology Services for their sponsor of today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as our webcast ends, so please take a moment to complete that because we use the information to improve our webcast in the future. So on behalf of Plant Engineering Magazine and L&T Technology Services, I want to thank everyone for attending this afternoon. Thanks, and have a wonderful afternoon.
Thank you.